So this is section 12.2, starts on page 816, and the first method, technique for evaluating a limit is direct substitution, meaning that if you can plug in x equals c, and it does not lead to undefined, then that's generally the answer. As long as we haven't picked out some kind of a funny equation that, like we had in the homework, that one actually would not have worked. It actually would have been defined for x equals 2, but it wasn't approaching the same thing. But unless you have some kind of like crazy piecewise function, that's not going to be the case. I mean, this function, right, x squared plus x minus 6, that's a parabola. It opens up, the y-intercept is -6, right? That's a function, there's no undefined point. So when they say find the limit when x approaches -1, are there any issues with plugging -1 in for x? Does it lead to an undefined? No. You're not even dividing. How could you be dividing by 0, right? So just plug it in. -1 squared plus -1 minus 6. Right? That's 1 minus 7, which is -6. But what about the second function? Does it have any points that are undefined? Any points of discontinuity in the graph?
Yeah.
What? No. X can't equal -3, right? If you substitute -3 here, you'd be dividing by 0. But that's not our problem, right? Because we don't want the limit as x approaches -3. We want the limit as x approaches -1. So it's not undefined for that point. So let's see what we got. If we plug in -1 into the numerator, we actually already did that because that was the last problem, right? That is -6. And if I plug in -1 in the denominator, -1 plus 3, -6 over +2, which is -3. So this is -3.